Hello, beautiful people. Continuity and behavior and symmetry. Beautiful. Okay, continuity. A graph is said to be continuous if there are no breaks or holes. Basically means it goes on forever and ever and ever and ever with no holes in there. But that's not always the case. So if there are breaks or holes, it is considered to be discontinuous. Okay, we should understand that. So there are three different types of discontinuity. This is a question on the quiz. Star this or do something. All right. So the first kind is where there's an asymptote. So it's an infinite discontinuity. It's where it's approaching some value, but it just gets really, really close, but it never touches that value. Okay, so there's an asymptote right about there. Right? The other kind is a jump. So it's like you're going along, and then the graph just stops, and so you have to jump up to the other graph. So it's called a jump. Wow. And then the last kind is called a removable discontinuity, or it's a hole. So like you're walking along, and then you just fall into this hole or something. That would suck. But that's what it is. It's removable. You can just take it right out of there. Okay, so we have the infinite, jump, and removable. Cool? So we need to determine if the graph is continuous. If it is not, we need to identify the type and location of discontinuity. So this first one, that is definitely not continuous because there is a break in it. So it's discontinuous, and there's a jump at x equals -5. Now, when you identify the discontinuity, it's always the x value. It's not the y value. It's always the x value. Okay? Now, this next one, there are two different kinds of discontinuities. So it's discontinuous, and there is an infinite discontinuity at x equals 2, because there is the asymptote right there. And then that should not be a jump. I lied. Liar. Gosh. You know, one day I'm going to be able to make a video without making a mistake. This is a hole at x equals 4. Cool? Not a jump, it's a hole. This last one, there are no jumps, there's no holes, there's no infinite anythings, so that's continuous. Okay, let's look at this. So now end behavior. So end behavior determines the ends of our graph. So as x approaches positive infinity. Now positive infinity is when the x's are getting bigger. So that is the right side of our graph. So if I look at the right side of this graph right here, this is going down and down and down and down and down and down and down. So that is going to negative infinity. Now if I look at the left side of this graph, which is when x is going to negative infinity, that's going to go up and up and up and up and up. So this, as x goes to negative infinity, f of x goes to positive infinity. Okay? Now we need to describe the end behavior of each graph. So let's look at A. If we're looking at the left side of this graph, that is going towards 0. So as x goes to negative infinity, f of x goes to 0. Now if we look at the right side of this graph, as x goes to positive infinity, f of x also goes to 0. Okay, let's look at B. So as x goes to negative infinity, f of x, that's approaching -3. The left side of this right here, that's approaching -3. So f of x is going to -3. If we look at the right side of this, as x goes to positive infinity, f of x is also approaching -3. Cool. This last one, or this one right here, as x goes to negative infinity, f of x is going to 2. And then as x is going to positive infinity, f of x is also going to 2. Okay, you can do those ones. Those are what you should get for them. And let's look at this. So symmetry. The graph can be folded along a line so that the two halves match. That's called line symmetry. So if we look at this graph right here, if we folded that on the x-axis, that graph would just fold right on top of each other, correct? If we look at this one, if we folded that, those lines would line up right on each other. Okay, so that's line symmetry. Now, point symmetry, the graph remains unchanged when it's rotated 180 degrees about a point. So, I don't know if I can actually show you this. Let's see. Maybe not. Okay, but say we have this graph right here. If we were to rotate it 180 degrees around that point right there, so we're just going to flip it this way 180 degrees, it would be the same exact graph. So if you want to like flip your phone upside down or something, it's going to be the same exact graph. Okay, if you're on a computer, then shucks. Okay, that's point symmetry. Now, the x-axis and the y-axis are common lines of symmetry, and the origin is a common point of symmetry. Okay, so we have a graphical test and we have an algebraic test to find these. So for the x-axis, for every point xy on the graph, the point x negative y is also on the graph. So that's when it's symmetric with the x-axis. And you can test that by replacing y with negative y, and it should result in the same equation. Okay, now if it's symmetric with the y-axis, for every point xy, the point negative xy is also on the graph. And you test that by replacing x with negative x. And then origin, you replace it with negative x and negative y. So you replace y with negative y, x with negative x. Okay, and let's go through some of these. So first we want to determine whether this is symmetric with the x-axis, y-axis, or the origin. So this first one, that is symmetric with the y-axis. Now to test that, we're going to replace x with negative x. I'm just going to plug that in. So negative x to the fourth minus 4 times negative x squared. Now negative x to the fourth is x to the fourth. Negative x squared is x squared, which is the same. So that is true. We just proved it algebraically. And there's that little happy smiley face. Okay, let's look at this one. Now this one is symmetric with the origin, because if I flip that 180 degrees, it's the same. See, we can go back and flip it. Flip, flip. So it is symmetric with the origin. Remember, symmetric with the origin, you replace y with negative y, x with negative x. So that's going to be negative x times negative y equals 6. Well, negative times negative is a positive, so xy equals 6. That is the same, so we just proved it. Cool? Let's look at this one. Now, this one, that is symmetric with the x-axis. Now, to prove that, you replace your y's with negative y. So I have 4 times x plus 3 squared plus negative y squared equals 16. Well, negative y squared is positive y squared, which is the same, so we proved it. This last one, that's symmetric with the x-axis, also symmetric with the y-axis, also symmetric with the origin. So let's start with proving the x-axis. The x-axis, you replace your y with negative y. So that's negative y squared minus x squared equals 1. So that's y squared minus x squared equals 1. It's good. Prove the y-axis, replace the x with the negative x, and you get y squared minus x squared equals 1. Origin, replace them both, and you still get y squared minus x squared equals 1. Cool? Now, even odd functions. So we just did all the symmetry stuff. Even odd is ways to describe symmetry. So a function is even if it's symmetric with the y-axis. And a function is odd if it's symmetric with the origin. So the way I remember this is odd and origin. They both start with O's. And then the other one, even and y. Or y get even. Right? Why get even when you could just be a nice person? Yep. Think about that. Okay, so, oops. Odd, origin, y, even. Why get even when you could be a nice person? Boom, there's a way to remember that. Okay, Let's look at this. So to determine whether it's even, odd, or neither, you're going to replace. So you always replace. Sorry, I got too caught up in my little mantras. So you're going to replace it with negative x. If you replace it with negative x and you get the same exact function out, then it is even. If you replace it with negative x and you get the exact opposite function out, so odd, origin, opposite, if it's the exact opposite, then it is an odd function. And then if you get something that's not the same or it's not completely different, then it's neither. Okay? So let's look at this. We're going to replace that with negative x. And when we do that, you get negative x cubed plus x. Now, x cubed turned into negative x cubed. Negative x turns into positive x. So those are both opposite signs. So this is f of negative x equals negative f of x, which means this is an odd function. Okay, let's do the same thing with b. And you get negative x squared plus 6, which is the same. So that is an even function. Look at this one. When you plug that in, you get negative x cubed minus x squared plus 2x. Now, the x cubed and negative x cubes are opposite, but the negative x squared and negative x squared stayed, and negative 2x and 2x, that's opposite, but it's not completely opposite, it's not completely the same, so that's neither. Okay, if we do this one, you get the same thing out, so that is even. We look at this one, and you get 8 over x, which is the opposite sign, so that is odd. Okay, on this last one, you plug that in, you get negative x plus 1, which is neither. Okay, remember to take the quiz. I will see you beautiful people tomorrow. Bye.